Chain rule is one of the most important rules when we have to find derivatives. When to use it? Well, let's consider a simple case. And that is pretty straightforward. All we have to do is bring 15 to the front and decrease the power. And we have 15 times x raised 14. But if I change the question, x squared plus 1 raised 15, then, well, should we FOIL to find the derivative? That is, write x squared plus raised 15 as x squared plus 1, x squared plus 1, times x squared plus 1, x squared plus 1, 15 times. Well, if you have a lot of time, go for it. So the answer is absolutely no. Should we use the product rule? "14 times. The answer is no. It's going to take a long time. So what do we have to understand here? This goes back to composition of functions. Suppose f of x is simply x raised 15 and g of x is x squared plus 1. Then f composed g of x would simply mean f of g of x, and every x in f would get replaced by x squared plus 1. So here we have x, so the x squared plus 1 would replace x in x raised 15. So we would end up having x squared plus 1 raised 15. So that gives us an idea as to when to use the chain rule. Chain rule is used when a function is within a function, that is, composition of functions. If you look at my example above, x squared plus 1 is inside x raised 15 to give x squared plus 1 raised 15. How do we go about finding the derivative? It's pretty straightforward. So we are going to treat x squared plus 1 as x. So what is the derivative? We have 15, x squared plus 1 raised 15 minus 1. But whatever we have inside is not just x, rather it is a function of x. So we multiply by its derivative, so we have 2x. So 15 times x squared plus 1 raised 14 multiplied by 2x. The answer is 30x times x squared plus 1 raised 14. That's it. You see how simple that is? So instead of doing, product rule 14 times or foiling it 15 times, it is unnecessary. That is the answer. And that is the idea behind chain rule. We call it chain rule because it sort of goes in a chain, and if you have to take the derivative one more time, you would kind of recursively go as a chain, and hence the name chain rule. So in the next problem, we have two algebraic functions, one raised to the power of 3, other raised to the power of 4. And if you FOIL this, it is going to take forever to find the derivative. So what we have to do is use chain rule. U is x squared plus 1 raised 3. I'm going to treat whatever that is inside as x. So the derivative of x cubed is simply 3x squared plus 1 raised 2. But keep in mind, in the inside, we don't have x, we rather have x squared plus 1. So we multiply by the derivative of 2x squared plus 1, which is 2x. V, similarly, is x squared minus 1 raised 4. V prime, if I treat x squared minus 1 as simply x, I have 4 times x squared minus 1 raised 3, but multiply by the derivative of the function inside, I get 2x. So now I could use product rule. F prime of x is simply u v prime plus v u prime. U is x squared plus 1 raised 3. V prime is 4 times 2x times x squared minus 1 raised 3. V is x squared minus 1 raised 4 multiplied by 3 times 2x times x squared plus 1 squared. I have a 2x in common. I have x squared plus 1 squared in common between those two terms. And I have x squared minus 1 cubed in common between those two terms. So if I pull 2x out, I'm left with 4 times x squared plus 1 cubed times x squared minus 1 cubed plus x squared minus 1 raised 4 times 3 times x squared plus 1 squared. If I pull x squared plus 1 squared out, I have 4 x squared plus 1, x squared minus 1 cubed, plus 3 times x squared minus 1 raised 4. Finally, if I pulled x squared minus 1 cubed out from those two terms, I'll have 2x times x squared plus 1 squared times x squared minus 1 cubed multiplied by 4 times x squared plus 1 plus 3 times x squared minus 1. I can simplify the term inside. Four x squared plus 4 plus 3x squared minus 3, which would give me 2x times x squared plus 1 squared times x squared minus 1 squared, 7x squared plus 4 minus 3 is 1. So here, t plus 1 over t minus 1 is inside t cubed. So the function that is inside is that. So to find the derivative, we are going to treat whatever that is inside as t. So the derivative would be 3 times t plus 1 over t minus 1 raised to multiplied by the derivative of t plus 1 over t minus 1. That is the function that is in which is inside. So let me do d over dt of t plus 1 over t minus 1 separately. We need to use quotient rule. Numerator is u, denominator is v. U prime would simply be 1 and v prime would be 1. So the formula here is v u prime minus u v prime divided by v squared. So that would mean we have t minus 1 times 1 minus t plus 1 times 1 divided by t minus 1 squared. So that would give us t minus 1 minus t minus 1 divided by t minus 1 squared. The t's would go away and we'll have negative 2 divided by t minus 1 squared. Mind you, that is not the answer. We have to take this answer and plug it in here. So the answer to the original derivative is 3 times t plus 1 over t minus 1 squared multiplied by negative 2 over t minus 1 squared. So the answer is negative 6 t plus 1 squared divided by t minus 1 times t minus 1 squared is t minus 1 cubed. Okay, here is a problem to find the derivative of a function using chain rule. If we simply had y is equal to x cubed, then y prime is 3x squared. But that is not what we have here. We actually have 3x squared minus 2 cubed. So we have to treat whatever that is inside the parentheses here as another function. By all means, we can see it as 3x plus 2, 3x squared minus 2, moving into the function, bumping the x out to get 3x squared minus 2 cubed. This is what we call, this entire process is what we call composition of functions, something that is covered in algebra. So what is the process here? We are going to treat the part that is inside the parentheses as x for a moment. So recognize that the derivative of x cubed is 3x squared, so 3, the inside part, 3x squared minus 2, but we have to multiply it by the derivative of the term that is inside, which would be 6x. So the final answer would be 3 times 6x, which is 18x multiplied by 3x squared minus 2. So here is another example that simply uses the power rule and the chain rule. So we have y is equal to x cubed plus 2x squared raised negative 1. So that is the function within the function x raised negative 1. So y is equal to x raised negative 1. So the second function is x cubed plus 2x squared. It goes in, bumps the x out to get the function y equals x cubed plus 2x squared raised negative 1. So if the shaded part were to be just x, the derivative would be minus 1 multiplied by x raised negative 2. But since we have the shaded part instead of x, we have x cubed plus 2x squared raised minus 2 multiplied by the derivative of the term inside, which would be 3x squared plus 6x. We have a common factor of 3x between the two terms. If we pull that out, we have minus 3x multiplied by x cubed plus 2x squared raised negative 2. And x plus 2. We may leave the answer as is, or we could also rewrite it as minus 3x multiplied by x plus 2. And if we move that term to the denominator, it would simply become x cubed plus 2x squared raised 2. So here we have to use a combination of quotient and chain rule to find the derivative. The numerator is u, the denominator is v, and f prime of x is v u prime minus u v prime divided by v squared. So u is 3x. V is x cubed minus 4 squared. U prime is simply 3. V prime, on the other hand, would require chain rule because we don't simply have x squared, we have x cubed minus 4 squared. Again, we have the function x squared. X cubed minus 4 goes in, and we end up getting x cubed minus 4 squared. So we are going to treat the x cubed minus 4 as x squared for a moment and recognize that its derivative is 2 times x cubed minus 4. But since x cubed minus 4 replaces x, over here, in terms of composition of functions, we have to multiply it by the derivative. The derivative here is 3x squared minus 0, which would simply give us 6x squared multiplied by x cubed minus 4. So f prime of x would be v, which is x cubed minus 4 squared, u prime 3, u 3x, v prime 6x squared multiplied by x cubed minus 4, divided by v squared, which is x cubed minus 4 squared, because v is x cubed minus 4 squared. We have a common factor of 3 in both terms, and we have x cubed minus 4 in common. So 3 multiplied by x cubed minus 4. If we pull that out, we are left with x cubed minus 4 minus 6x cubed times 1 divided by x cubed minus 4 raised 4. So we will have 3x cubed minus 4 multiplied by x cubed minus 4 minus 6x cubed divided by x cubed minus 4 raised 4. Cancel out the common terms and simplify. We have 3 multiplied by negative 5x cubed negative 4 divided by x cubed minus 4 raised 3. So here is a problem which can be solved via distribution or using product rule. It's better to use product rule in this problem. So u is 7x plus 4 and v is x cubed minus 2x squared. The product rule states y prime is u v prime plus v u prime. So u is 7x plus 4, v is x cubed minus 2x squared, u prime is 7, v prime is 3x squared minus 4x. So we can plug that in here. 7x plus 4 multiplied by v prime plus v and u prime, which is 7. So we have an x in common, so over here in the first term, so x times 7x plus 4 multiplied by 3x minus 4 plus x squared times x minus 2 times 7. There is an x in common between those two terms, so if we pull that x out, we have 7x plus 4 times 3x minus 4 plus 7 times x minus 2. Of course, we can simplify this further. (21x squared minus 28x plus 12x plus 7x minus 14) x times 21x squared minus 9x minus 14, and that would be the final answer. So all we have to use in this case is the product rule. So here we want to find y prime with respect to t, and we have two functions that are in product, so that is multiplied with that. So u v prime would be u v prime plus v u prime. U is 2t, v is square root of t plus 6. We can write square root of t plus 6 as t plus 6 raised 1/2. Now u prime would simply be 2. If v were to be square root of t, then we can differentiate it directly. But here we have t, that is the variable. The function is t plus 6, goes in to give t plus 6 raised 1/2. Which implies that we have to use chain rule. So treat whatever we have inside as t. So t raised 1/2 is 1/2 t plus 6 raised 1 over 2 minus 1 multiplied by the derivative of the inside term, which is 1. So we have 1/2 t plus 6 raised negative 1/2. So now we can take those values and plug it back in y prime. 2t multiplied by square root of t plus 6 plus, v prime is 1/2 times t plus 6 raised negative 1/2 plus v is square root of t plus 6 multiplied by 2. Those two would go away. So y prime would be equal to t multiplied by t plus 6 raised negative 1/2 plus 2 square root of t plus 6. We may leave that as is, or we could write it as t over square root of t plus 6 plus 2 times square root of t plus 6. We can simplify it even further by getting a common denominator. By multiplying and dividing by square root of t plus 6. We know that square root of t plus 6 times square root of t plus 6 is simply t plus 6. Now that we have a common denominator, we can combine the numerators. T plus 2t plus 12, which would give us 3t plus 12 divided by square root of t plus 6. If we pull 3 out, we have 3 times t plus 4 divided by square root of t plus 6. So here is a problem which is very simple if we recognize that the problem has to be done using chain rule. So what to note here is we have x cubed that entire part would be our imaginary x. You may even call it as u. So we have x cubed 4x squared minus 5 over 2 minus x, which is another function, goes in, displaces the x to give us 4x squared minus 5 over 2 minus x cubed, which tells us that we have to use chain rule. So if the shaded part is just x, y prime would be 3, the shaded part, raised 3 minus 1. I'm going to call that shaded part as u, so we have to multiply it by the derivative of the inside, which in this case is u prime. So y prime is 3 multiplied by 4x squared minus 5 over 2 minus x raised 2 times u prime. U is 4x squared minus 5 over 2 minus x. U prime would then involve quotient rule. So I'm going to call the numerator as A, denominator as B. So a is 4x squared minus 5, b is 2 minus x, a prime is 8x, b prime is 2, u prime per quotient rule would be b a prime minus a b prime divided by b squared. So we have 2 minus x multiplied by 8x minus 4x squared minus 5 multiplied by 2 divided by 2 minus x squared. Distribute and simplify. 16x minus 8x squared minus 8x squared plus 10 divided by 2 minus x squared, which will give us 16x minus 16x squared plus 10 divided by 2 minus x squared. We have a common factor of 2, so if we pull that out, we have 2 8x minus 8x squared plus 5 divided by 2 minus x squared. So now that we have found u prime, we can take that and plug it in here. So y prime would be equal to 3, 4x squared minus 5 over 2 minus x squared multiplied by 2 times 5 plus 8x minus 8x squared divided by 2 minus x squared. I could write the middle term, well, I could combine the 3 and the 2 to get 6. I could separate the middle term and write it as 4x squared minus 5 squared divided by 2 minus x squared multiplied by 5 plus 8x minus 8x squared over 2 minus x squared. That is the best we could do in terms of simplification, so we could write it as 6 times 4x squared minus 5 squared multiplied by 5 plus 8x minus 8x squared, entire thing divided by 2 minus x squared. So here we have a problem which uses chain rule as an application, where we're trying to find the equation of the tangent line to the graph of the function s of x at the point 3, 1 over 2. So we have a point, we know the point slope form y minus y1 equals m times x minus x1, y minus 1/2 equals m times x minus 3. All that is missing is m. How do we find m? We find the derivative and we plug in the value of x. So how do we find the derivative? We have s of x is equal to 1 over square root of x squared minus 3x plus 4, which I could rewrite it as x squared minus 3x plus 4 raised negative 1. S prime of x, we will treat whatever that is inside the parentheses as x, would then be minus 1, x squared minus 3x plus 4, minus of minus 1, which is minus 2. But since we don't have x, rather we have x squared minus 3x plus 4, we have to multiply by its derivative. Derivative of x squared is 2x, and derivative of minus 3x is minus 3. So we have minus 1 multiplied by 2x minus 3. Let's move the term in the middle to the denominator. We'll end up getting x squared minus 3x plus 4 raised to. If I distribute the negative, I'll have 3 minus 2x divided by x squared minus 3x plus 4 squared. So the slope m would simply be equal to s prime of 3, which is the x1 value we have. So that would give us three minus 2 times 3 divided by 3 squared minus 3 times 3 plus 4 squared. 3 minus 6 is minus 3. 3 squared minus 3 times 3 will get cancelled. 4 squared is 16. So we end up having negative 3 over 16 as the slope. Y minus 1/2 would equal to 3 over 16 with a negative, x minus 3. Y minus 1/2 would then be equal to negative 3x over 16 plus 9 over 16. Y would equal to negative 3x over 16 plus 9 over 16 plus half. We could take the common denominator and combine the last two fractions. So y would equal to minus 3x over 16 plus 9 over 16 plus 8 over 16. Y would equal to negative 3x over 16 plus 17 over 16. Since we have a common denominator, we can combine it as negative 3x plus 17 over 16. And that would be the equation of the line tangent to that particular function at 3, 1/2. Here is a problem that follows a similar approach. We have x1, y1. x1 is 2, y1 is 2. So the equation of the line is y minus y1 equals m times x minus x1. We have y1, we have x1. We simply have to find the slope m. To do that, we have to find the derivative. So y is equal to the 5th root of 3x cubed plus 4x, which is 3x cubed plus 4x raised 1 over 5. Inside the parentheses, we have 3x cubed plus 4x, and not just x. If it were to be x, we can find the derivative directly. So using chain rule, if the shaded part were to be x, the derivative would simply be 1 over 5, 1 over 5 minus 1. So the part inside is 3x cubed plus 4x. Since it's not x, rather a function of x, we have to take the derivative of the term that is inside. The derivative of that is 9x squared plus 4. So we have 1 over 5, 3x cubed plus 4x, 1 over 4 minus, 1 over 5 minus 1 is minus 4 over 5. I can move the term in the middle to the denominator, so I would have 9x squared plus 4 divided by 5 times 3x cubed plus 4x raised negative 4 over 5. What is the slope? The slope simply is y prime evaluated at x is equal to 2, or in this case x1. So we're just going to plug in, should probably write it as x is equal to x1, which is 2. So we will have 9 times 2 squared plus 4 divided by 5 times 3 times 2 cubed plus 4 times 2 raised negative 4 over 5. Numerator would simplify to 40. Two cubed is 8. 8 plus 3 is 24. Plus 8 raised negative 4 over 5. We could cancel that to get 8. 8 divided by 32 raised 4 over 5. With a negative, which is the same as saying 8 times 32 raised positive 4 over 5. Now we could write 32 as 2 raised 5. And using the properties of exponents, I could write 2 raised 5 raised 4 over 5 as 2 raised 5 times 4 over 5. Those two would go away and we would have 8 times 2 raised 4, which is 128. So the slope m is 128. So y minus 2 would equal to 128 times x minus 2. Y minus 2 would equal to 128x minus 256. Y would be equal to 128x minus 256 plus 2. Y is 128x minus 254. Therefore, the equation of the line tangent to the given function at the point 2, 2 is y equals 128x minus 254.